Hello and welcome. Today's topic is the p-n junction diode. A p-n junction diode is a semiconductor device that allows current to flow in one direction and blocks it in the reverse direction. It is the most basic semiconductor device and forms the building block of many electronic components. Structure of a p-n junction diode. One p-type region contains an excess of holes, positive charge carriers, due to doping with trivalent impurities, example boron. 2 n-type region contains an excess of electrons, negative charge carriers, due to doping with pentavalent impurities, example phosphorus. 3 depletion region, a region at the junction of the p-type and n-type materials where mobile charge carriers recombine, creating a region devoid of free charge carriers. Formation of a p-n junction. 1 diffusion, when the p-type and n-type materials are brought together, electrons from the n region diffuse into the p region and recombine with holes, and vice versa. 2 depletion layer, the recombination forms a region depleted of free carriers, leaving behind immobile ions, positive ions in the n region and negative ions in the p region. This forms a built-in potential barrier. 3 equilibrium, at equilibrium, no net current flows across the junction, and the electric field created by the ions prevents further carrier diffusion. Working of a p-n junction diode. 1 forward bias. Connection, the p region is connected to the positive terminal of a power supply, and the n region is connected to the negative terminal. Effect, the external voltage reduces the depletion region and the built-in potential barrier. Result, current flows as electrons and holes cross the junction. 2 reverse bias. Connection, the p region is connected to the negative terminal of a power supply, and the n region is connected to the positive terminal. Effect, the external voltage increases the width of the depletion region and raises the potential barrier. Result, only a very small reverse saturation current flows due to minority carriers. If the reverse voltage exceeds a critical value, then breakdown occurs. p-n junction diode equilibrium, forward bias, and reverse bias. Characteristics of a p-n junction diode. 1 forward bias region, current increases exponentially with voltage once the threshold voltage, 0.7 volt for silicon and 0.3 volt for germanium, is surpassed. 2 reverse bias region, a small reverse saturation current flows until breakdown voltage is reached. 3 breakdown region, at high reverse voltages, avalanche or Zener breakdown may occur. Key parameters. 1 threshold voltage, the minimum forward voltage required for the diode to conduct. Silicon, 0.7 volt. Germanium, 0.3 volt. 2 reverse saturation current, a small leakage current due to minority carriers in reverse bias. 3 breakdown voltage, the reverse voltage at which the diode conducts heavily in reverse bias. 4 peak inverse voltage, PIV, the maximum reverse voltage the diode can withstand without breakdown. Applications of p-n junction diodes. 1 rectification, converting AC to DC in power supplies. 2 clipping and clamping circuits, shaping waveforms in signal processing. 3 voltage regulation, in Zener diodes. 4 signal demodulation, extracting information from modulated signals. 5 switching, used as a switch in digital circuits. Types of p-n junction diodes. 1 standard diodes, for general rectification. 2 Zener diodes, designed to operate in reverse breakdown for voltage regulation. 3 LED, light emitting diode, emits light when forward biased. 4 Schottky diodes, low forward voltage drop and fast switching. 5 photodiodes, operates under reverse bias and generates current when exposed to light. Diode circuits. Forward bias circuit. Reverse bias circuit. Thank you for watching.